Welcome back to this part of the session of building materials and construction. In the ninth part of the session, we have dealt with respect to the usages of the fine aggregate. Whereas in this part of the session, we go for learning about one of the most ingredients required for the concrete and maybe in the manufacturing or even the processing of the concrete, laying, all the phases of an operation, care has to be taken with respect to the usage of the material. That kind of material, we call it as a coarser in nature, and the aggregate we call it as coarse aggregate. Today we shall discuss related to what are the types of an aggregate, what are the importance, and finally what are the tests that are being conducted for the determination of the various physical properties as well as mechanical properties of the coarse aggregate. In the current curriculum, you have only some of the tests pertaining to the mechanical properties as well as the physical properties of the coarse aggregate. Thermal as well as chemical properties, that is not present for your part of the syllabus. That is an extra part which is also conducted in the laboratory. Now, let us move on to the term coarse aggregate. What does the term coarse aggregate? As I told in the previous class, aggregate means the arrangement or the fragment portion that are being retained, which are larger in size and which is retained above 4.75 mm sieve, passing through 80 mm and retained to 4.75 mm. That kind of the materials which fall under this category, we denote it as a coarse aggregate. Now, where do you going to use the coarse aggregate? Obviously in the concrete part of the usages. Even the aggregates are also used for the roadway works. If you go for taking in the case of the asphalted type of the roads and all, obviously aggregates is essential. Meanwhile, aggregate has also been utilized for the water as well as wastewater treatment plant, using as a base material as well as a filtration material also. Other than this, the larger part of the aggregates which are also used for the ballast in the railways. In addition to that, we have certain other usages also, even for the recreational as well as aesthetic purpose. But major thing it is when it is particularly used for a large scale construction purpose with respect to the reinforcement or for the foundation, or maybe for the floor construction, or maybe for the usages of the column and even for the beams and all, along with the reinforcement, how it has been done. This part of an aggregate matters much. Now, the coarse aggregate is broadly classified into two parts. What is that? It is classified as a natural part of an aggregate where the sizes are naturally originated. That kind of an aggregate we call it as natural aggregate. Either it may be due to the sedimentary deposit or maybe the weathering phenomena, we call it as a thermal disintegration phenomena taking place, as well as the action which are being responsible for disintegration of the rock fragments which are being retained there, either to the bed rock itself only or the parental rock, or if it is being carried away through the rivers or any other things which is being retained. Sometimes they are disintegrated products due to the high portion of an elevation, the fragments tends to break up and move apart along with the wind action also. These are the natural part of an aggregate. The aggregate which are being manufactured through the aid of the crushing machine is what we call it as an artificial aggregate. These are the two broad ranges of the classification. In the next thing it is the aggregates which are also obtained not like the crushing of the rocks and all. Along with the rocks, if you have the same size of the particles or the materials which are available, maybe a part of a slag content which has been burnt up, the replacement is also being carried out. That kind of the materials we are going to call it as artificial aggregate. So this part of the artificial aggregates is also coming under the usage. Even in the case of the bricks, we call it as a broken bricks. Broken bricks. Okay. Now, if the aggregates are utilized for different sorts of usages, how are you going to test it? Obviously, we have a tag name for the manufacturing of the cement or maybe for the bricks and all. What about in the case of an aggregate? How you can able to determine it? You have different sorts of companies even for the cement and reinforcement structures and all, but what about in the case of an aggregates? And for that, major thing is to determine what is the shape, size as well as texture. This is the fundamental aspect that you need to learn it for the construction. Mainly the shape as well as the sizes also matters much. Shape of the aggregate may be a rounded in nature or maybe an angular in nature, or it may be irregular in nature, longer in nature, or maybe thickness will be lesser. These are the critical part of the shapes that are being coming across, a rounded or angular or irregular, something else. Next, regarding to the size, if the size of the aggregate is quite bigger in nature, therefore the area of exposure will be slightly lesser, and what about the case of requirement of the mortar will also be quietly less, and the vice versa for it. Texture, obviously the shape of the aggregates mainly depends upon the reduction ratio, how much amount of the boulders or the rocks which are being carved out from the quarry when it is being transferred into the crusher, what was the initial part, the final part of the aggregates which are being crushed out in terms of in different sizes which are being available. They may be the shapes falling under the irregular or maybe a regular sort of in category. That ratio is also being important. Next thing we come across here is related to the texture content. Texture content is mainly depend upon whether it is a hardness as well as the grain size of the material. Texture, whether it is harder in nature, rougher, so therefore it offers a good bonding. Soft part of the texture, smoothness content, poor bonding takes place. Therefore, the workability also tends to increase in the case of the smooth type of the materials. Let us get to know according to the shape as well as the sizes. So we have the different categories. We have an angular aggregate, irregular aggregate. Finally, we also have a rounded aggregate, aggregates which are longer in nature, and aggregates which are having this lesser part of the thickness, we call it as a flaky aggregates. And even we also come across the length of the aggregate tends to be more. The length, if it is being tends to be more, we call it as elongated aggregate. Let us get to know one by one. Angular aggregate. Angular aggregate means they have a proper sharp wedges or the sizes, or it may be blunt in nature. That if it has been blunt in nature, the size is not completely a uniform in nature, it is irregular. The shape cannot be completely defined. That we call it as irregular aggregate. They possess the complete interlocking mechanism. Interlocking mechanism. When they possess the interlocking mechanism, therefore good bondage is also present, and if at all in the case of the voids which has been left it out, smaller fragments of the sizes, they tend to come across in between the voids, and the arrangement or the package of the aggregate will be compact in nature. This is the one of the usages that we come across in the case of the angular aggregate. Next thing it is, if you are going to take in the case of the irregular part of an aggregate, they have a interlocking mechanism also it involves, but slightly it is different from the angular part of an aggregate. Whereas in the case of the rounded aggregate, the voids content will be more because of the roundness content, because of the smooth condition. Texture is smooth, not rough in nature. Therefore, in the case of the rounded aggregate, the voids content will be more. What about in the case of the flaky? Flaky means you might have observed in the advertisement and all, Kellogg's Corn Flakes or any other thing. Flakes means, or whatever, if you see the beaten rice also, it is flaky in nature. If you take the case of the chips and all, whatever the things you are going to eat it, they have lesser part of the thickness but slightly longer in nature. Okay. Same thing here also, flaky content means the aggregate thickness is comparatively lesser in nature. Thickness is lesser in nature. Next, what does the presence of the flaky aggregate tends to do? The workability is altered, and whatever the graded part of an aggregate or the concrete which is obtained, it leads to the poor concrete. Poor concrete. The flakiness also causes the segregation and even the bleeding in the concrete. What about in the case of elongated, though it is having the larger size, thickness is also okay more, but the length is more. Length, if it is being said to be more, again what happens, elongated part of an aggregate, it affects the strength and durability. Affects the strength and durability. The strength and the durability, it matters much here. Observe it carefully, the picture. So, the elongated part of an aggregate shall not tend to be more than 15% of the mass. 15% of the mass of the aggregate, which is taken on a whole. Therefore, we have a separate test for this flakiness content, we call it as an index, and if it is in the case of an elongation, we call it as the elongation index. The tests are to be conducted. Now, moving on to the sizes. Size of the material, as I have told, larger the size, obviously lesser will be the amount of the mortar is required. lesser the size, larger will be the area of the exposure, and the mortar required, or the paste or the thin film which is required will also be tend to be more in nature. Now, moving on to the texture content. Texture content plays a vital role. Here, if you are going to take in the case of the aggregates, as I have told, they have rough as well as the smooth texture. Rough texture, obviously it imparts hardness in nature, the grain size, it imparts the hardness, surface will be harder in nature. Texture, it is normally suitable for irregular as well as the angular aggregate. If it is in the case of, in some other cases, not all the part of the irregular aggregates, some of them, they also tend to exhibit, especially the rounded aggregate, they have a smoother in texture. Smoother in texture, it mainly implies related to the lesser, or what we call it as a poor bonding. When the bonding has been poor, it cannot be, tends to stick up one to another. Hard grains materials, they tend to stick up easily, the bonding will be good. Here the voidness content will be more, and therefore texture is also a critical concern related to the usage of an aggregates. Now, another thing it is, higher surface area requires more space for the lubrication. More lubrication, whereas the smoother part, it is requiring only the lesser part of the lubrication. Whatever the materials, we call it as rounded aggregates, you can also see in the case of the river part of the banks, which are completely sedimentary deposited, and the abrasion of the materials, what happens, it tends to make the surface smoother in nature. That is one thing. Major thing for the smoothness content, you can see in the case of any of the recreational purpose which they go for utilizing it, but it is not completely utilize it for the construction purpose, only in the partial means. Next part of the concept that we go for taking it is, though we have the shape, size and texture, how they have been graded. The gradation is also an important one. An aggregate is classified as 3 types of the gradings. What are those? Observe it here carefully. We have a well graded aggregate, we have a well graded, next we also have a gap graded, and apart from this we also have a poor graded. How do we go for it? Observe it here, especially in the case of the fine aggregate, we have the CU sizes and all. Similarly, for the coarse aggregate, we also have a separate set of the CUs, and that consists of a retainment and passing. If there is a considerable amount or the percentage of the materials which are being retained on all the CU sizes, for example, if you are going to see here in terms of an the CU numbers and all, okay, this is here quite different. This is a CU numbers, CU sizes, 80 mm, 40, 20, 10, 4.75, 2.36, 1.18, 600 micron, then followed by, and 10th one, this 150 micron, and you also have a pan at the bottom. Okay, these are the things. Now, here in this particular part of the case, if there is a considerable amount or the percentage of the materials which are being retained on this sieves and all, then we call it as well graded. Considerable amount of retained meant in on the sieves. Gap graded. Gap graded means maybe 50, maybe 80 passing, 20 has been retained, and again 10 completely it has been passed, 4.75 is retained, and 2.36 it has been retained more, like that you have, or like that kind of an aggregate, we call it as a gap graded kind of an aggregate, where certain part of the passings are being completely taking place, but it is being completely blank in nature. That kind of an aggregate, we call it as a gap graded type of an aggregate. So, two size range will be missing in nature. Missing in nature. That kind of an aggregate. Poor graded means it is an opposite of the well graded, here where the considerable amount has been retained on the sieve, whereas in this part of the case it is unevenly distributed. The uneven retainment which you are going to see in the sieves, we call it as a poor graded. Uneven distribution, or what we call it as a retainment and passing on the sieves, we call it as a poor graded. Percentage of the passing will be completely, maybe 50% is being retained here, the remaining 10% here in the 4.75 another 20% here, 50 plus 20, 80, and then again 20%. This kind of an retainment, we call it as a poor graded type of the aggregate. That kind of the aggregate shall not be utilized for the concrete mixing purpose or making purpose or designing aspect. It will be detrimental in nature. Therefore, always you need to go for using the well graded kind of an aggregates. Clear with this concept? And moving on to the next part of the concept, it is related to the test of the aggregate. Before the test of an aggregate, why the grading is tend to be much more significant? Let us get to know. Significance of grading especially in the case of significance of the grading, it has to give a good workable condition, good workability with minimum requirement of the bleeding as well as segregation if it is being present, but it has to give the good workability content. Here good workability, it also refers to the mix of the fine aggregate, coarse aggregate, cement and water. And in this part, well graded aggregate, it has a maximum density when it is being compacted. When it is compacted. Two conditions you need to remember, minimum and maximum conditions, where you need to have the optimum part of the concrete mix. Second thing, it is good workability means obviously it has to ensure the smaller aggregates passing through the voids and in the presence of the larger part of the contents. So that is also useful in nature. So well graded aggregates also use it for the proper mix design of the concrete. Next, what is the maximum as well as the minimum conditions? Thing it is the amount of the paste which is required, the binding material, the minimum paste is required for the maximum compaction, okay, for the maximum compaction, and it also increases the strength and durability of the concrete, which maximizes the strength as well as durability of the concrete. Voids content will be minimized. Due to interlocking mechanisms. And passing of smaller fragments. In between the voids content. Okay, these are all the significance where it has a good workability with the maximum density upon the compaction. Minimum paste is being required when it is being completely compacted due to what? The interlocking mechanism, and if the voids are also present, smaller fragments of the coarse aggregate also tend to pass on for that, making much more tighter in nature, and amount of the paste or the mortar which is being required will be lesser in nature due to the more surface area of the contact. What happens? More amount of the particles has the sizes that has to be reduced. In the literal sense, if you take it here, the void content, if it has been minimized, then you have a minimum paste where you can achieve the good strength as well as the durability in the concrete. It is nothing but the workability content, the measure in which the concrete is being mixed under the optimal conditions, so that whatever the materials or the ingredients that have been added, they are as per the IS standard requirements only. The quality of the materials matters much. If the quality is good graded, then you can achieve all these things. If the quality is gap graded, no, not a way. Slightly you have some crackings and all shrinkages. Major thing it should reduce the shrinkage. These things you're going to study in a concrete technology in the 4th semester. Poor graded, obviously segregation and bleeding tends to take place. Whatever the mix that you're going to use it, they are not completely or compactly arranged, they are loosely arranged. Voids are more. When the voids are more, obviously what happens? The aggregate to the fine aggregate, the coarse aggregate ratio, or water to cement ratio, whatever the things that you have calculated for it, it is not in a proper conditions. Therefore, care has to be taken while considering the shape, sizes as well as the texture of the aggregate. Now you have come across the concepts of natural aggregate, artificial grading as well as the significance. Now it is a time for testing the quality of the materials. Testing the quality of the materials, which is used for the engineering purpose, mainly to determine the structural, or what we also call it as the strength properties, which is also denoted as the mechanical properties of the materials, along with the gravimetric analysis. Okay, let us get to know the test one by one. First part of the test that I am going to cover up is related to determination of the fineness modulus content of the coarse aggregate. Fineness modulus content you have come across in the case of the fine aggregate also. Similarly, here you can see the size of the particle or the ranges will be having more dimensions. These are coming under the category of the coarse aggregate and the finer one. Meanwhile, you need to think that even the deposition of the coarse aggregate, where they have like a cone type of a deposition, due to the abrasion as well as the impaction, what happens, the particles, they have a limited load of the capacity, they tend to set up a crack, and later on it disintegrates much more into smaller fragment particles. That has to be minimized in the on-site facilities. That is where we call it as storage of the coarse aggregate and its maintenance. Moving on to this similar part of the fine aggregate, you have the sieves from 80 mm, 40, 20, 10, 4.75, 2.36, 1.18 mm. Then you have 600, 300, 150 micron and a pan content. Okay, this is the major aspect. Only thing is we need to see that 4.75 mm is to be taken, because this is coming under the finer part of the category. A pan is also being kept here. Finally, you go for determining what is the sieve, utilize it in an ascending order. Ascending order means 4.5 at the bottom, then 10 mm, then above it 20 mm, 40 mm, 80 mm. Take the sieve pans, and then the different sieves are to be arranged in an order wise. Finally, take at least 5 kg of the coarse aggregate. Okay? If you take a 5 kg of the dry part of an aggregate, finally you need to transfer all those contents on the sieve, start to sieve for a period of 10 minutes, not more than that, less than 10 minutes itself only, and afterwards you need to transfer the retained part of the contents of coarse aggregate into a tray wherever you come across for 80 mm, 40, 20, 10, 4.75 mm. You need to take the weight that has been retained. That will be having here. The remaining part means it is weight retained will be not there. There is a one conditions. Next thing it is cumulative weight retained. For example, here it is represented in terms of an kg. For 80 mm passing, here if you have like 0.2 kg or 0.1 kg itself only, then cumulative retained is equal to 0.1. If you have 40 mm, then 0.2. What happens? 0.2 plus 0.1 is 0.3 kilograms. Similarly, 0.1 divided by 100. Okay? Or maybe in another sense, if you have more than the 0.5, here what happens? 6 will be, so 0.6 divided by 100, like this, or whatever the grams, if you're going to take it, that factor, or maybe in terms of in kilograms, the unit rate of the conversion has to be done properly. Then finally, whatever the things that you're going to get it as a summation F, that component, if you take in terms of in grams, so therefore it is 100 grams. 6 kilo means, sorry, 0.6 grams means 600 grams divided by 100. Okay. Cumulative weight which has been passing, weight that has been retained, now you are going to have it. The percentage which has been retained, you go for adding it. So 0.6 by 100 like this, so on. Finally, cumulative percentage of the weight which has been passing. Something if it has been retained here, 0.1% is being retained. So therefore, next thing it is 99% is being subjected for the passing. Likewise, we have, if it is in the case of 0.01, so therefore you have 99.9 percentage. Okay, so 0.02 you have 99.92, or sorry 99.98, like that you have. So like this manner you compute what is the cumulative percentage of the weight which is retained, taking all the fractions, summation of this divided by 100, it has to give you the fineness modulus content. The determination of the fineness modulus is taken. So maximum it is related to up to 4.75. Remaining things which is being retained will be taken or calculated as 100 itself only, because no things shall tend to pass there, but only the C's which are being arranged till here. Fine with this? So however you have calculated the fineness content, you need to determine it, and finally you need to determine what is the fineness modulus content of the aggregate. This is the one thing. Next sort of the test that we have is related to the coarse aggregate, especially moisture content and determination of the crushing strength, aggregate impact, and then abrasion type of the test. What about all those things which will be covered up in the next part of the class? Till then, remember all the sorts of the concepts and stay tuned for it, and thank you one and all.